Feeling comfortable with pH? Because if you're not, you should probably go back to the video on pH. We're going to talk about now where this idea of neutral comes from and where this idea of pH and pOH comes from. And what we're going to work with is the equilibrium constant for the dissociation of water. So liquid water, H2OL, will do what's called auto dissociation. It will break apart into H plus and OH minus. And again, some professors will say this is H3O plus. It's not going to change our answer. This has an equilibrium constant, Kw. Now, Kw is equal to, at room temperature, 10 to the negative 14. So if we write the equilibrium expression, Kw equals the concentration of OH minus times the concentration of H plus. But since we have liquid water, we're not going to include our equilibrium expression. So this tells us H plus times OH minus is going to give us 10 to the negative 14. So if we want to convert between OH minus concentration and H plus concentration, if we've got one, we're just going to take 10 to the negative 14 and divide it by the other one. So our concentration of OH minus is just 10 to the negative 14 divided by the concentration of H plus. And the concentration of H plus is just 10 to the negative 14 divided by the concentration of OH minus. This also tells us that as the concentration of H plus gets smaller and smaller and smaller, this ratio gets bigger and bigger and bigger. So as our H plus decreases, meaning that our pH goes up, our concentration of OH minus is also going to go up. So when we start exceeding 7, this is when we start seeing this number being bigger than this number. Conversely, as H plus starts getting bigger and bigger, this tells us that this ratio also has to be getting bigger and bigger, which means the concentration of OH minus is getting smaller and smaller and smaller. But there's one other relationship we can use. If we take the negative log Kw, this is going to be the negative log of 10 to the negative 14, which is going to be 14. But we can also take the negative log, the concentration of OH minus times the concentration of H plus. And what we're going to do is we're going to use a property of logs that says the log of the product of two numbers is just the log of one number plus the log of the other. So it's going to be negative log 10 concentration of OH minus plus log 10 the concentration of H plus. And if we distribute this negative, we get negative log 10 of the concentration of OH minus plus negative log 10 of concentration of H plus. And this by definition is the P. So we get pOH plus pH equals 14. So we have this other relationship we can work with. Our first one is going to be the relationship based off the equilibrium constant, and the second is going to be that the pOH plus the pH has to equal 14.
So where does this idea of a neutral solution come from? Well, let's take a look back at our equation that says pH plus pOH equals 14. Now for our neutral solution, we have equal amounts of H plus and OH minus. And so also if we take the negative log based on that, we get that the pH and the pOH are the exact same. So if we make the substitution that pH equals pOH, we find that actually twice the pH equals 14. And when we solve for the pH, we get that the pH for a neutral solution is in fact 7.